Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNS CT. So today I'm here to discuss about the lecture series on the IoT system design. So in the previous lecture series, we have discussed about what is Raspberry Pi and the features of Raspberry Pi. So here in this session, let us discuss about the Raspberry Pi interfaces. So this Raspberry Pi provides several communication interfaces which allow us to interact with more external hardware devices such as sensors, displays, motors, cameras, and other microcontrollers. So these interfaces are very much essential in IoT, embedded systems, robotics, automation, and smart applications. So first, let us discuss about the empathy part, design thinking stage empathy part for this type of interfaces, that is the Raspberry Pi interfaces. So here we have to first consider how the user feels. So for example, for smart home, so the user would want to connect the sensors and devices easily. The communication between the modules should be fast and reliable, and also they need a low cost platform for this IoT applications. And also the interfacing should be very simple, and also the board should support the wireless communication. So how these multiple sensors communicate differently, so which interface is best for the application, and will this Raspberry Pi support? So all these challenges can be done with the help of this Raspberry Pi, so which connects the sensors using GPIOs, I2C, SPI, and UART protocols. So the program interfaces here is done using Python libraries, and the test communication between the modules, which uses a Wi-Fi and Bluetooth for wireless application. Also builds IoT and automation project using different interfaces. So hence, focusing on all these challenges, the user always needs the easy hardware interfacing, reliable communication, faster data transfer, low power consumption, flexible connectivity, etc. So all these could be met with the help of this Raspberry Pi board. So here the one challenges faced here would be the difficulty in understanding the protocol difference, wiring complexity, and the pin configuration errors. So first, let us discuss why this Raspberry Pi is being widely used. So as we have discussed in the empathy part, the functionalities of each interface, understanding the interfaces of these Raspberry Pi, and the applications of these particular interfaces, which depends on our need, and the interfaces where we can integrate everything to build a project. So these parameters are analyzed, and we are making use of Raspberry Pi in most of the smart home and automation applications. So as already discussed, so we know what is Raspberry Pi. So this is defined as a mini computer size, which is in the size of credit card. So that is interoperable with any input and output hardware device like monitor, television, mouse, keyboard, etc. And it is a fully featured microcomputer which is squashed onto a circuit board measuring approximately 9 centimeter into 5.5 centimeter. So this is a small size mini computer, credit card sized thing, which is having interoperability feature. So first let us discuss about the GPIO interface, that is general purpose input output. So these are programmable pins which is available on Raspberry Pi board, and they're used for digital communication with external electronic components. So the features here are it is having 40 pins in the modern Raspberry Pi boards, and this works at 3.3 logic, and it can act as input pin, output pin, or the alternate function pins. So we have the power pins, ground pins, GPIO pin, special pins, etc. So the main application of such kind of interfaces are the LED control, push button interfacing, relay control, motor driving, and sensor interfacing. For example, If a button is connected to a GPIO input pin, it is pressed high level. When it is released, it indicates low level. So if an LED is connected to an output pin, if it is high, the LED is on. If it is low, the LED is off. So this is easy to program, supports multiple protocols, and it is a flexible usage. And one limitation here is it cannot provide high current directly. It is sensitive to over voltage. So the next is the I2C, that is inter-integrated circuit. So this is a two-wire serial communication protocol which is used to connect multiple devices using addressing. So here we have two lines, that is SDA and SCL. So that is serial data and serial clock. So this is based on master-slave communication. So here the Raspberry Pi acts as a master and the devices are identified by the unique addresses. So the main application of these type of protocol is for temperature sensor, OLED displays, RTC modules, EEPROM memory, etc. So here the main advantage is only two wires are required and it supports multiple devices. And the limitations here is this is lower than SPI. So the next is SPI, that is serial peripheral interface. So this is a high-speed synchronous communication protocol. So here we are having the four types of pins, SPI pins. That is MOSI, which is master out slave in, MISO, master in slave out, SCLK, that is clock signal, and chip select, that is CS. So here Raspberry Pi will act as a master and the clock synchronizes the communication. So if you discuss about the application, here it is for RFID modules, LCD modules, ADC, etc. So the next is UART. So that is a universal asynchronous receiver transmitter. So this type of protocol, it is mainly a simple wired protocol, and here it works on serial communication process. So this can connect GPS modules, Bluetooth devices, and other serial peripherals. So it is having a configurable baud rate, and debugging can be done easy in this type of. So the next is the USB ports. So USB allows connection of the peripheral devices like keyboard, mouse, webcam, pen drive, etc. And we have different versions like USB 2, USB 3, and also the speed for first is standard and for third version is faster. So these are the applications like the first version for keyboard, etc. And for the third USB 3, it is for printers, external drives, webcams, etc. And then is the HDMI port. So HDMI provides audio and video out. So high definition video support is provided here. One for audio transmission, supports monitors and TV. So main application is for desktop computing, multimedia system and digital usage. So display interface. So here we have a DSI, that is display serial interface. So that connects Raspberry Pi touchscreen displays. So interactive, this is smart displays, portable systems, custom displays, etc. So these are mainly for display purposes. So the overall mind map of today's session is, so we have discussed about various Raspberry Pi interfaces like I2C, SPI, UART, HDMI, display interfaces, and USB. So today's assessment, which Raspberry Pi interface is mainly used to connect sensors and external electronic components. So that is the GPI, general purpose input output. Which interface on Raspberry Pi is commonly used to connect a monitor or display? So HDMI, high definition multimedia interface. Thank you.